of our sun, which is enormous, just too big to imagine. And after a supernova, it starts collapsing, just collapse into a small sphere about perhaps the size of New York. This means that it has practically infinite mass and infinite density, which means, in turn, that it also has an enormous gravitational force. Next. So, how do they form? At least that we know of, all black holes form from supernovas, or a death of a really giant star. There's a really confusing or interesting fact that happens when it starts to collapse. There is something called the event horizon, which I will explain in the next slide, that is at the center. That is where all the mass is concentrated. So when we say a star is starting to collapse, as it gets closer to the event horizon, it starts going slower and slower and slower, until it finally touches the event horizon and stands as a frozen collapsing object in time. As I said, the event horizon. This is this black ball that you can see right here. It is, we can call it the point of no return. Any object that goes into the event horizon, it cannot get back out, or at least that we know. It's completely impossible. It is also called that because beyond that point, we can't see anything. It's just like a black hole, exactly a black hole. You can't see what's inside. Therefore, if an event happens inside of the event horizon, it's impossible for us to detect or see. Another really interesting thing about the singularity. The singularity can be considered as the very center of the black hole. This means that it is the point in the very center, which concentrates all of the mass of the star. Therefore, it's a little spot with infinite amount of density and infinite amount of mass. That is where they suppose everything goes once it collapses into the black hole. How can you see a black hole?